Hey guys, welcome back to another video. In this video, we're going to be looking at transformations of polynomial functions. So let's take a look at the different transformations. If you're watching this video, you've probably already seen transformations of more basic functions. This is more just a general video over all polynomial functions and transformations we can do. So we have horizontal transformations, that's your side-to-side movement of functions. Vertical translations, that's up and down movement. Reflections, remember there's two types of reflections. You can either reflect over the y-axis or over the x-axis. And it's done differently. If it's over the y-axis, you're just negating the x itself. So right here, you're just negating the x itself. But if it's over the x-axis, you're negating the entire function. So the signs of everything in the function, all terms in the function change. And then we also have stretches and shrinks that we get by multiplying a number by the entire function. So it's a stretch if it's a number greater than 1, and it's a shrink if it's a number between 0 and 1. All right. So those are our different transformations. So let's look at a few example problems. For this first one, we're supposed to describe the transformation and then graph each function. So let's see. So our original function is x cubed, and that would look something like, let's say this is our origin. It would look something like this. I missed my origin, but that's okay. And then we are transforming it down 9. So let's say each one of these boxes is worth 3. So 1, 2, 3. So here's down 9, we'll say. So our function will be something more like this. So it got transformed downward 9 units. All right, let's look at one more. Actually, let's find one that's maybe a little more difficult. Let's work number 6. And number 6 looks pretty easy too. Let's do number 5. Let's do number 5. 5 looks more interesting. So, and does it say to describe? Okay, so we went down 9, by the way, over on this one. This is down 9. Okay, let's do number 5. So the 1/8 out front is a shrink. So we did a shrink by a factor of 1/8. So we did shrink 1/8. And we also negated just the x itself. So that is a, let's see, that's a reflection. A reflection in the y-axis. Reflection in the y-axis. And essentially what that'll do is the shrink will make it like more shrunk down vertically, so it'll be like more compressed outward. And then the reflection in the y-axis will just flip it, so really it won't even look any different since it's a reflection in the y-axis. It'll probably look exactly the same because it kind of flips on itself. Let's see, x to the 4th, what does that function look like? We can always look it up in Desmos. So I'm going to pull Desmos over here and show you. All right. All right, so x to the 4th looks like that. So it kind of looks like a, well, my face is in the way. There you go. So it kind of looks like it's a parabola, but it's more like flat on the bottom. So let's say this is the origin. So our original function was kind of just flattened out right down here and then went up. So if we're going to shrink this, and if we were going to shrink it, it'll be more like compressed out this way. So it'll be more like this, This is a really terrible drawing, but you get the idea. And then it's reflected on the y-axis, so essentially it just flips around. It flips around like this, which we won't be able to tell any difference because it's right on top of itself. Okay, let's look at something else. So let's see, number 7, graph the function on the same coordinate plane as f of x. So here's our original function. Now let's look at the transformations. So we have a negative sign out front, so we're negating the entire function. So that's going to be a reflection in the x-axis, right? So it's going to flip it upside down, and then this is going to move it to the right 3. So we go 1, 2, 3. So we're going to be right here, and then we're going to be flipped upside down. So it's going to look something like that, right? So right 3, and then it's the whole function has a negative sign out front, so that's a reflection. Okay. This is write a rule for g, and then graph each function. Describe the graph of g as a transformation. Okay, so let's look at g. So we are just going to negate the x, so that's going to be a reflection in the y-axis, and then we're also moving down 9. So if we changed our original function, so here's the original function right here. If we did that to the original function, we're going to change the sign just of x. So we're going to have negative x cubed. We had plus 8, but then we also are doing minus 9 on the end. So plus 8 minus 9 will give us a minus 1. Okay. So again, we move down 9 here, and then we have a reflection in the y-axis. So in that case, it will look, we can go ahead and pull Desmos up for our graphing. And we can do negative x cubed minus 1. So here's what our function will look like. All right. So just remember what each of your transformations do, and you won't have any problem. Okay, let's look at these last ones. Write a rule for g that represents the indicated transformation. So we're going 1 unit left. We're going to have a reflection in the x-axis, and we're going to have a stretch by a factor of 2. Okay, so let's do these one at a time. Let's do 1 unit left. So this is going to get a little bit interesting because we have 2 x's, but that's okay. So it'll look something like this. If we were to do g of x, g of x equals 1 unit left is going to look something like this. So x plus 1 cubed minus 6 x plus 1 squared plus 5. Okay. So notice we did the plus 1 on both of the x's. And then also we're going to reflect in the x-axis, so that means that we are going to negate every single term for reflection in the x-axis. So let's do h of x to show that. So we're going to start with g of x, and we're going to reflect it. So we'll have negative x plus 1 cubed. We're going to change the sign as well, so that'll be plus 6 x plus 1 squared, and then this will be minus 5. So you change the sign of every term when you reflect in the x-axis. All right, and then finally we have a stretch by a factor of 2, so that means we're going to multiply each term by 2. So let's do L of x is our final answer here. So we're going to have a negative 2 x plus 1 cubed. And then we'll also put a 2 here too. So 2 times 6 is 12 x plus 1 squared. And then also a 2 times this, so 2 times 5 is 10. So you can see with stretches and shrinks, you just multiply by whatever factor they say. And that's it, guys. So if you have any questions about transformations, hit me up in the comments. If you like, leave a like, and I'll see you next time.